Okay, folks, welcome back to Mathland. We're starting chapter 3 today. Yay! Here are all of the solutions to your homework assignment from page 116. Check them out, make sure you're good. Hopefully a lot of nice, easy review type stuff. Elijah says he's gold, so we're going to just leave them behind. So if you got questions on it, you'll need to come see me or Mama or Papa or Uncle Joe or whoever you know. Can figure it out, man. We're building this great cathedral. We'll make sure we get the foundation poured just right. Okay, pause if you need. And I am pushing forward to a quick review of section 1-2. These are notes. This is probably about the third page, second page. Elijah, do you remember what the word is means?
Equals.
Is means equals. True. And I'm going to throw this up on the screen. All right. All of these different ways are translations, if you will, for addition, subtraction, multiplication, and division. Right. This is going to be real key to section 3-1. All you're doing in section 3-1 is some translations and creating equations. All right. Very, very simple stuff. All right. So come back, review those, make sure you got those. Just building up. Skyward we go. All right. So center that up for you. There we go. Section 3-1. We're doing stuff as simple as a, okay man, 1/2 of a number minus 10 is equal to the number. Well, what's the number? We don't know. You have to use a variable, okay? So I said, again, just as a quick example, 1/2 of a number minus 10 is equal to the number. We got to be able to take stuff like that and translate it into math. How about it, Eli? Well, it's just what it says.
1/2 times
1/2 times
n.
Times n. Of means multiply. You need to remember that, folks. Okay, he's going to use n for a number. Does it have to be n? Could you use a different letter?
You could.
You could use a Greek letter if you wanted to. But 1/2 n minus 10. Oh, minus 10 is equal. All right, equals x. It says half of a number equal to the number.
Oh, n.
So you need to stick with the same variable, n. All right. So that's a quick example there. How about example 2? How about the sum of c and twice d? The sum of c and twice d is the same as. What about that?
C plus 2d equals 20.
Equals 20. Okay. Sum does mean add. Okay. Twice d, so to do 2 times d, same as equals 20. All right. So again, if you have any issues, I encourage you to go back to section 1-2. Okay. Review 1-2. The language of math, folks. Got to have that down. We got a nice little chart that you can look back at and make sure you got that stuff down. All right. They do talk also about problem solving. Okay, they're going to give you a lot of words, handful of word problems. Okay, man, let's solve that problem. All right. I got a couple little funny little type cartoons you can look at just in terms of problem solving. This is a fun little critter friend of mine. All right. Tips for solving math problems. Hey, man, look for a pattern. Look for a pattern. All right. That's essentially what math is. Really, just kind of study of patterns. And my little friend says, because look for a pattern. Because math is always logical and usually predictable. I gotta agree. That's why I love math. There's a right and a wrong. It's always, you know, it's real clear cut. There's no gray. It's logical and predictable. Yeah, not like people. I'm with you there, Fred. Good job. All right, so we're going to look at, in addition to Fred's little advice, we're going to give you a 4-step problem-solving plan for your notes, okay? 4-step plan for solving problems. Problem solving. Okay? Alright, here we go. What do? You got a big, huge, nasty word problem like, oh, I don't know. How about, let's see. Max has a balance of $650 in his savings account. If his balance is increased by $50 each month, which, go ahead and write an equation that would describe a balance of 1,000 after n months, and then tell me, yeah, when does he get to a balance of 1,000? Okay, so anyways, real world math comes in word problems. It's, you know, you're never going to be walking across the street. You're never going to be heading down the sidewalk and get slammed with a math problem that looks like this. Oh my Henry, look at that! 1/2 n minus 10 equals n. Oh, we're going to have to solve that. You don't walk down the sidewalk and slam your face into that. That don't happen. Okay? You deal with reality and the world and people and things and quantities of stuff. And yeah, you got to go with that. All right, so anyways, that's why this is so necessary. And it kind of freaks people out. So step 1 is simply to explore the problem. Explore. Hey, men love to explore. We were born to explore. Okay, explore the problem. So you got a problem, let's solve it. Solve it. So how do we start? Explore. Ask yourself stuff like, what do you know? What do you know? It's a good question. Make a note of it. Ask yourself something like, what am I looking for? What am I looking for? What am I trying to find? Okay, that's step 1. Step 2, you then plan. Make a plan. Plan the solution. Okay? Start piecing together the puzzle with a plan. You'll want to use a variable, all right? That thing that you're looking for, okay? Go ahead and use a variable, okay, to represent what you're looking for. It's the unknown. Okay, introduce a variable. What else? See if you can write an equation. Write an equation. If possible, right? A lot of these problems you're going to be doing, yeah, that's the deal. All right. If you actually get that far, you get an equation, right? Got an equation? Solve it. Solve. Proceed. Work it out. Run the numbers. Do the figuring. And there's one more step, though, and this is a very important step, and that's to examine, thoughtfully examine, carefully examine the solution. Okay. I'll add. Does it make sense? Does it make sense? Is it reasonable? Let me show you what I'm talking about. Tips for solving math problems. Make sure your answers make sense. This is step 4, folks. So here's my 2 little friends having a little conversation, and they are doing a little problem solving themselves. And they are hooting any good time. It's a hoot. Look at this. So she's doing her calculations right here. She says, well, my answer is 44 hours. And this little gal over here, she's done her calculating. Well, really, my answer is 127 meters. Well, either way, it's a lot of tomato juice. That's what I said. Seriously? You knew you were looking for a quantity of tomato juice. I got 44 hours. I got 127 meters. That's a lot of, that's a lot of tomato juice. Okay, and obviously that's ridiculous. But more realistically, people are doing math problems. Oh goodness, I went right off your screen. Sorry folks, here's the rest of our notes. I knew I was going to do that at some point. That's what you missed, eh? But yeah, realistically, you know, people are making estimations as to how long it's going to take for them to get from Detroit to Chicago. You know, if I travel at 70 miles an hour, stuff like that. You know, and one kid comes up with 3.5 hours, and another kid says it's going to take 17 days traveling by car at 70 miles an hour. 17 days. That's not reasonable, right? So you got to make sure that your answer actually makes some sort of reasonable sense.
17 hours versus
Okay.
17 days.
Yeah, is it reasonable? Okay, let's do one little example here with burgers and French fries. Now this one's a little ridiculous as well because, you know, when it comes to burgers and French fries, you go, you order, you pay for it, and then you eat them. Bottom line, I'm gonna eat it. I ain't gonna do math with my burger and French fries. So I gotta say, I think this is all kind of ridiculous, but we will tolerate or humor the authors of our textbooks and do some math with burgers and French fries. So let's just say that a burger is $1.50 more than the French fries.
Damn French fries.
Okay? And we will also say 4 times the cost of the burger minus the cost of the fries, minus the cost of the fries is $8.25. Okay. Question then, how much are the fries? How much are the French fries? And again, this is ridiculous because if I'm standing there at the McDonald's, I just look up at the menu and it says the fries are $2.25. That's how much they are. You ain't gonna do this sort of thing. So it really is kind of ridiculous, but whatever. We will humor the authors for coming up with such a silly problem. It does give us a fine chance to exercise the 4-step problem-solving plan, and which step 1 again was to explore. Elijah, what do you know? Do we know anything here?
Yeah, that a burger is $1.50 more than fries.
Oh yeah, we do know that. Do we know anything else? Oh yeah, 4 times the cost of the burger minus the cost of fries, $8.25. So we have these 2 items. I know this, there's 1 item, and I know this. I know 2 things there, all right? And the second part of that is, what am I looking for? Do you even know what you're looking for?
The cost of the fries.
Oh yeah, oh it's right there, that's what I'm looking for. That's the question right there. There's a question. I'm looking for how much of the fries. All right, so second step, plan the solution. Use a variable to represent what you're looking for. What am I looking for? The cost of the fries. What? So we pick a variable, doesn't matter which. I think in my notes I used F. Okay, so I'll say something like this. F equals the cost of the fries. All right, reasonable? Of course. So start with that. What else can we say? Do we know how much? This burger is $1.50 more than the fries. Ooh, let's do that. Let's do that. The burger is $1.50 more than these guys. So could we write an expression for the cost of the burger?
Yeah.
What would that be?
F plus minus.
Wait, minus?
Wait, no, 1.
It says $1.50 more than. Isn't that plus? So if you take the fries.
F plus 150.
right? And f plus 150, that'd have to be the cost of the burger,
Equals
right?
burger.
Okay, equals the cost of the burger. Okay, all right. So we now know that the cost of the two items in terms of two different variable expressions. One costs f, the other costs f plus 150. Now you can take that and work with the second piece of information, right? 4 times the cost of the burger. Oh, so that's 4 times this, right? Minus, subtract, minus the cost of the fries. That's this. Is means what?
825.
Yeah. No, is means equals. Is means equals 825. So we can now go and write that expression. Okay. Or write that equation. Okay. Again, it said 4 times the cost of the burger. 4 times the cost of the burger was, again, f plus 150, right? Minus the cost of the fries is what it said. Is means equals 825. All right, so we have completed the first 2 steps of the problem-solving approach. Now to finish it out, yeah, you solve it. You think you remember how to do this stuff? Today we're doing a really easy version.
1 minus 1, no.
But you actually, I'm gonna help you out. You have to distribute first. We gotta clean up this left side. So it's gonna be 4f. What's 4 times $1.50? Multiplied by 2 twice. 2 twice. $1.50 times 2, $3. Times 2, $6. See how easy that is? Bam. When you multiply by 4, multiply by 2 twice. Because 2 times 2 is 4. Alright? Alright. Now, if I got 4 francs, and then I eat 1 franc, let's put that together. These are like terms. 4 francs, let's kill a franc or eat a franc. That's 3 francs left. So 3f plus 6 equals 825. You remember what you're supposed to do next from your pre-algebra days?
Yeah, minus 6.
From both sides, what did you do one side, you do to the other? So that's 3f is equal to 225. Divide both sides by 3, right? Do the opposite operation. So f is equal to 2 1/4 divided by 3. That'll come up to be 75 cents. Okay. Ta-da! Simple, huh? Folks, that is section 3.1. Section 3.2 is even easier. We're going to throw that one in there as well. I'm going to show you how it's just one step. They're one-step equations. Okay. It's just add or subtract something from both sides. Let's do the hardest thing I can think you'll find. All right? We're just going to do one. Just one problem. Here's the hardest problem I think that you'll come across, in my opinion. What's the first thing you think you ought to do to that problem, Eli? If we had to solve, you're told to solve from y.
I would try to do 4/5 plus 2/3.
All right. I'll tell you this. Most students, I always try to encourage them to clean stuff up. And we can clean this up. You can either go with keep, change, or don't subtract, man. Add the opposite. So I'm going to turn the subtraction into the addition of the opposite. Okay? So really all we have here is y plus 4/5 equals 2/3. What did you say that you wanted to do? Oh, he's changing his mind. He wants to go ahead and subtract, because the opposite of addition is subtraction. So he's going to subtract 4/5 from both sides. See, if you clean that up, you'll avoid those mistakes, right, Elijah? Yeah. Okay, so 4/5, subtract 4/5, that's gone. All you have left is y on the left side. 2/3 minus 4/5, without a calculator. Oh no, I can't. Yes, you can. Common denominator, right? We're going 15ths. 15ths. Top and bottom by, what do we got?
3. So 12.
And keep in mind that was negative.
10.
All right. So 10/15 minus 12/15. All right? I got 10, I owe you. I got 10, I owe you 12. What do you say?
Well, that means they still owe 2.
All right, so negative 2/15. That's my answer. What if you were asked to check your answer? Do you know how to do that?
You add 2/15 plus.
Check. Well, what's that? I thought once you got an answer, you just walk away, man. You say, wee, I'm done. No, you just go ahead and take that and plug it in. Plug it in, plug it in. So you go negative 2/15. Looks just like this. That was minus a negative 4/5. Okay, I'm going back to the original, just putting the negative 2/15. I remember it was minus a negative. And then you say, question mark, does that really equal 2/3? That's all you do to check your answer. All right? And we'll work that out right quick. So, again, I'm going to keep change on that. Or add the opposite. Now, in order to do this, I'm going to have to multiply top and bottom by 3. So, that'll be 15, and 4 times 3. I'm going to scratch that, make that a 12. Great. So, what's negative 2 plus 12?
Negative 10.
10. So, I have 10/15. Does 10/15 equal 2/3?
Yes.
Yeah, when you reduce that, it sure does. Checked. Done. All right. I'm just going to stop right there because I think it's section 3-2 is just that easy. Okay?
Conquer something for Uncle Ben.
Henry's awesome, isn't he?
Conquer.
I love you, Henry!
Conquer.
Yeah, man! All right, folks. Here is your homework for section 3-1, 3-2. Oh, by the way, we took some celebrations yesterday, didn't we? All right.
I can make us some wine.
I guess we ought to show you a thing or two. Well, normally I don't like to make a public display, folks, but man, that right there is awesome. Way to go, Elijah! He did miss a couple. We'll probably talk about some of that stuff he missed. Hopefully you get your celebration back sometime real soon and have a discussion with your teacher about things that you're not understanding. Because again, remember, we're trying to build a cathedral here, and it's going to be beautiful. Particularly if you lay a nice foundation, all right? If you don't lay that good foundation, if you're not learning from your mistakes, by the time you get done, you got to put that steeple on top and put the bell into the tower. The whole thing's going to come crumbling down. It's going to be really sad and pathetic. All right? One day you're going to be getting into some pre-calculus, calculus stuff, and we want to be able to survive all of that. All right? Great. Super-de-duper, man. Do good. Be great. Stay off the streets, man. Be a saint. All right, folks. Over now.